Hello, geometry class, reporting live from Office 130. We're going to talk about the volume of a sphere, so we don't have to in class. So hopefully you watch this little YouTube video here that I'm playing that shows you how a sphere's volume is just two cones put together, the volume of two cones.
In a previous video,
so there he is putting
we saw that it took
the water of one cone in
to fill
so that would be the hemisphere.
With the same radius.
So it's essentially two cones, and then they show you how if you add in the volume of these two cones and you just kind of like pretty it up, that's going to give you the formula for the volume of the sphere. And you can watch that as slow or fast as you want. There are other ways to derive it. I like this one. So it's 4/3 pi r cubed. So let's remember that and put it on our notes. Let's go full screen here as you're reading my to-do list in the corner. That's great. How do I make this big? Full screen. Okay, so what do we say? 4/3 pi r cubed. How do I type on this? Oh, I don't. Let's do this. Okay, so it's 4/3 pi r cubed. And that's the volume for a sphere. So a sphere, bear with me, I'm doing this on a trackpad, so I don't have very much control. It's a three-dimensional circle. And just something to note is that the radius goes in all directions. Your radius is from the center outwards in any direction. So it could be right there. You can see that radius. Or it could be going straight up. And that's the radius. Or it could be coming towards you. All of those distances from the center to the outside of the sphere, that's the radius. So just note that. And we also had this word, a great circle. So that's the largest circle you can draw. Remember we talked about that's an example of an equator or a prime meridian. So you can pull the radius from any center to like that outer boundary of the sphere. And it's going to be 4/3 pi r cubed for the volume. So here's a simple problem. Find the volume of a hemisphere with a radius of 3 inches. So a hemisphere is half a sphere. So the radius is 3. Not too bad at drawing that. So this is just simply to find the volume of the entire sphere. We'll do 4/3 pi r cubed, and 3 cubed is 27. And now don't grab a calculator. Let's do this on our own. We can do 3 and 27 down to 9. And then 9 times 4 is 36. So if it wasn't cut in half, the volume would be 36 pi. So that's the volume of the sphere. But the volume of the hemisphere is going to be half of that. So we'll cut it in half. That's the bell. I don't know what that means. Does that mean lunch is over? I don't know. Hopefully I'm not supposed to be teaching. So that's 18 pi. And its volume, so we're going to say inches cubed. That's how many 1 by 1 by 1 inches cubes, those little cube guys, fits into that hemisphere. And that's your answer. That's your exact answer. Throw in the calculator. That's your approximate. So here's a better problem. What is the largest sphere to be cut from a cube of wood? So it's a cube, so all the dimensions are the same. This is 12. This is 12. That has a side length of 12. And then what percentage of wood would be carved away? So we need a plan. What is the largest sphere to be cut from a cube of wood? Well, so if it's going to be in the center, it would have a radius of 6, right? 6 left, 6 right. That's as big as you could get. So to answer this largest question, it's going to have a diameter of 12. What percentage of wood would be carved away? What we're going to do is we're going to find the volume of the cube and subtract the volume of the sphere. And what that's going to do is that's going to give us all the remaining bits and pieces on the outside, as illustrated by my squiggly drawing there. Okay, so the volume of a cube is the area of the base, which is 12 times 12, times the height, which is 12. So that's just 12 cubed, wouldn't you know it? That's where that comes from. And then the volume of the sphere is 4/3 pi r cubed, and r is 6. And let me just get a calculator. Get your handy dandy calculator ready, and we can do that. So it's 12 cubed, that's 1728. Anybody know what happened that year? I don't. French Revolution or something? No, I'm sorry, French Indian War. 4/3 pi, 6 cubed, so 6 cubed is 216, divided by 3, times 4. This is going to be 288 pi. And that's the best we can go. We can't combine those, they're not like terms. But then let's put a unit on here. This is volume, this is centimeters squared. I mean cubed, because it's volume. So now remember what this is. This is everything in that cube except for the sphere. That's what would be carved away if you're going to carve out this sphere from that shape. Okay, last one. Find the volume of the plastic needed for this hollow toy component. Somebody made that up. This doesn't have to be a toy. For this random hollow hemisphere. The outer hemisphere diameter is 5 inches and the inner hemisphere diameter is 4 inches. So what we can do for the volume is we can find the volume of the large hemisphere, so L hemisphere, that's what that stands for, minus the volume of the small hemisphere. Now something to note, if the volume of a sphere is 4/3 pi r cubed, maybe you want to add this to your formula sheet, but the volume of a hemisphere, so half of that, if I cut 4/3 in half, that's 4/6. So, right, 4/3 times a half is 4/6. That's going to be 2/3. So if you just want to remember that, a hemisphere is going to be 2/3 pi r cubed. So for the large, r is 5. And then for the small, oh, not 5, that's the diameter, so 2.5. Tricked. Okay, 2.5. Don't do that. Don't do what I did. All right, and then the small one, the radius is 2. So we'll do 4/3 pi 2.5 cubed. I didn't need parentheses. I just feel like the decimal, I want to group it. Cubed. And then we're going to subtract that inner hemisphere, this guy here, where the radius is 2. So that's, oh, I put it, hold on. We want to make that, I put 4/3, I meant to put 2/3. This is 2/3, because I can't find the eraser. Oh, here it is. And that's going to be, is my face really in this whole thing? Minus 2/3 pi 2 cubed. And then you could simplify this, but since it's in a decimal, that's fair game to me to grab a calculator. Times 2.5 cubed. Yeah, I don't know how they want us to. 2.5 cubed is like a weird decimal, so we're just going to go the decimal game and multiply by pi and everything. 2/3 pi times 4. So I got approximately 24.35. I'm rounding to the 100th place. What are we in? Inches cubed. That's the volume taken up by this like hollowed out half shell here. So really what to take away is this formula. Make sure you add it to your Unit 10 note card, 4/3 pi r cubed. If you want to find the volume of a hemisphere, just do that cut in half. And that formula cut in half, our visitor, is 2/3. 1 second. And now I will end this video if I know how to. And